I would like you to be able to write a function in terms of this. So let's get this out of the way for a second here. Okay? And because we need this here, right? This stuff. If we want to make this into a function, either one of these. Now, I don't want a specific value at 18. I want it to be a function now. So I'm going to say e of t. If I want to know, if I want to write a function for this, I can say some value that I happen to know, e of 0, whatever it is at 0, plus the integral from 0 to t, except now I need what do I need in here? There and there. Can't use t. You need a dummy variable in there. It's some stand-in for t when you write the function because you want to emphasize that here's where the variable is in the function. So you use u or some other thing, right? It doesn't matter. R-U-D-U. Rudu. This is a function where that upper limit of integration here is the variable, how far you're going. If you looked at it basically, if you had a function, if you had a function here for this, the upper limit of integration is where you're going here. So you're going from here to here, right? This is t, okay? This is the area underneath this, right? If this is r of u here, right? This is the rate that you're eating at, or whatever it is. The area underneath there is the amount you've eaten. This is the variable here. This is going to move, right? If we change this now, that's how we make this into a function, right? If this moves, the upper limit of integration, it took so long to open this thing before I should actually use it, right? I'm not sure whether this will fit the eating thing, especially when we get into the negatives there, okay? This is some crazy function, right? This is the starting point, and we started it at 0, right? We're writing it as a function where this is the variable. So I use t in the thing I gave you, but so up here it's bad because I'm using t as a dummy variable, and this is the upper limit, but let's ignore that for now. As a matter of fact, I can't get it out of the picture. So if this represents the rate that you're eating at, it's continuous. The rate you're eating is, I know in reality that's not true. It's not like you're eating and then you slow down, you speed up, you slow down, then it goes negative, and I really don't want to know. I don't want a description of this, but we start at this point, nothing's being eaten, right? At midnight, all night long, you're constantly eating. Okay, I know this doesn't make sense, but you're constantly eating. The area underneath is the amount you've eaten, right? You slow almost down there to... It's not really changing. You notice on the side here, this is the area over here, just to show you, right? You're eating. You stop for a little bit. You keep eating here, more. You slow down. Yes, you throw some up here. You eat some more, throw some up, and then it all goes downhill. I don't know here how you could throw up more than you had in the first place, but okay. What is the rate of change over here related to? Because that's what we're looking at. We want to know what's the rate of change of that function that we wrote. We're writing a function here. Okay, let's look at this. We want to know now, are you okay with the fact that this is a function for the amount that you've eaten at any time t? Are you okay with that? Yeah. It's how much you had eaten at midnight plus the change in the amount eaten over the course of the day. What we want to know now is, what is the derivative of this? What is d dt of that function? Of E0 plus integral of 0 to t of r of u du. Or the other way you said it was d dt of e of 0 plus integral of, what was the other way you said it? Which is the better way for what we're looking at here. e prime of u du. Okay. I'm hopeful this could be the year that people actually understand the second part of the fundamental theorem of calculus. So this is the hardest thing, I think, to teach and to understand in this course. This is the fundamental theorem of calculus connects derivatives and integrals, and we're looking at the derivative of a function that involves integrals. So it's going to give us what we're ending up with here is going to be the relationship between derivatives and integrals. So for right now, we want to know what's the derivative of that. Intuitively, or what it means in our example here is, what's the rate of change of the amount eaten as you go here? Okay? What's the rate of change of this function? This is a function for the amount you've eaten at any time. You already know that because we started with that, right? What's the rate of change of the amount eaten? What is it? It's just r of t or whatever, right? Or it's e prime of t there, okay? Or e prime of t. Okay, we have this function here. We have this amount you've eaten at midnight plus the integral of this function here, right? You know that this should be just r of t, or in other words, it should be e prime of t, okay? The derivative with respect to time of this function. What's the rate of change? Let's go back to the graph for a second so you can see. No, we should look at this part first before we look at the graph again. What's the derivative of each piece here? You remember that if you have a constant, this is a constant, isn't it? This doesn't change in our function. That's just the amount you've eaten at the start. So what's the derivative of that? This doesn't contribute to the derivative at all, right? What's the derivative of this part have to be then? Yeah, it's better if we look up here, actually. Well, it doesn't matter which one you look at, because the u is the dummy variable. You don't understand the dummy variable? I know, and then he suddenly says, "Oh, what are we doing here?" Okay. This is the. I didn't say it. I just repeated it. It's fine. Let's just not worry about it, okay? We are. Yes, we are. Can we pause for? Maybe not. No, who am I kidding? Nobody's rating it at all. I'll rate it. Okay, we have. So we have this function where amount we started with plus the net change over the course of the day, up to whatever, right? Up to time t here. And if we want the derivative of this of course doesn't matter, right? It's 0 because it's the amount you started with. It doesn't change. The rate of change, right? The rate of change of this function, this is the amount you have eaten at any time during the day. The rate of change of that should just be this, right? If you have a function like this, so this is 0, what did you say this was? This was just r of t, right? R of t here. Because it's a dummy variable. We're connecting this from two ends. I'm saying this is the rate of change. We already know that. The way we develop this whole scenario is the rate of change that you're eating at any time is r of t, right? By definition. Plus, we also wrote a function for however much you had eaten at any time t by saying this is how much at midnight plus the net change over the course of the day. The derivative of this is just r of t. The derivative of the integral of some function is the function itself. Okay? Now, the other thing though is, notice it's kind of like we did this. We substituted this in for u, but we didn't do anything with this one. This didn't go anywhere, right? This didn't matter, right? This didn't matter. This was a constant, so it didn't matter. This mattered because it was the variable. The integral of, let's just write that part separately here. Extend the page again. Integral from 0 to t of r of u du. Okay, this is some function. This is some area function. The derivative with respect to time or with respect to t of that function is just, what do we say? R of, guys, I have to stop now. Look, we didn't get to do the final thing.